Hi everyone, this is me, Hussein Abdullah, and
And this is me, Waleed Afandi.
today we are going to present the Kgnet system, a graph machine learning enabled knowledge graph platform, and demonstrate the Sparkle ML query language. This work is under the Cognitive Data Science group at Concordia.
So, Hussein, why do we need GML-enabled KG platform?
This is an interesting question. There is a lack of integration between graph machine learning frameworks and RDF engines. Thus, data scientists manually optimize graph machine learning pipelines to extract the knowledge graph data stored in the RDF engines. Also, select appropriate graph machine learning methods that fits the graph data structure and the allowed computing resources. As we see, the traditional graph machine learning pipelines uses graph machine learning frameworks such as PyTorch Geometric and BGL to build custom pipelines, where the graph database engine itself is isolated from the graph machine learning pipeline. This isolation prevents graph machine learning frameworks from consuming automatically the knowledge graph updates, and as well prevents the trained graph machine learning models to be used through the Sparkle RDF query language. These graph machine learning methods also vary in their training strategy, training time, and memory requirements.
Interesting. So, how the KGNet system design can tackle these challenges?
As we see in the system architecture, the Kgnet is an on-demand graph machine learning as a service on top of RDF engine that extends existing RDF engines to support graph machine learning Sparkle queries that we refer to as Sparkle ML. The graph machine learning as a service component automates the training of graph machine learning models. The Sparkle ML as service component parses, optimizes, and rewrites the Sparkle ML queries into standard Sparkle queries and maintains and manages the trained model's metadata.
So, how KGNet allows seamless integration between RDF engines and the trained GML models?
Yeah, actually, Kgnet introduced KG Meta Knowledge Graph as a graph representation of graph machine learning trained models metadata. The KG Meta interlinks between the KG data and graph machine learning models. As we see, the graph machine learning task is represented as a nodes. Each task has a set of graph machine learning models, where each model has a set of attributes like the training hyperparameters, the inference time, the model accuracy, and etc.
So, how KGMeta helps to write a Sparkle query?
Yeah, actually, the Sparkle ML is more like a standard Sparkle query. The lines in 6 and 7 are standard Sparkle triples that select this paper and title from a DBLP knowledge graph, where the lines from 8 to 11 are user-defined graph machine learning triple patterns that are parsed and rewritten as HTTP codes to apply the inference.
So, how KGNet optimizes the Sparkle ML query?
Yeah, this is an interesting question. Actually, we have two phases of query optimization. The phase one is graph machine learning model selection. As we see, we have different graph machine learning tasks. Each task has various graph machine learning methods, where each method has different model accuracy and inference time. Kgnet allows optimization to choose the highest score models or the lowest inference time models, or using integer programming optimization to allow both the highest accuracy and lowest inference time selection. The second phase is user-defined predicate ordering. As we see, the graph machine learning user-defined predicates will be translated into HTTP calls. The higher number of HTTP calls will hurt the query performance. The first formalization we have is an HTTP call per node, and the second one is an HTTP call per the GML query. Kgnet decides the form to use based on the graph machine learning model and the query cardinalities. Now I'm going to show the Google Colab notebook that uses Kgnet system to run Sparkle ML queries, where all GML models are assumed to be trained and ready for inferences. The user can write Sparkle queries to explore the Kgnet knowledge graph data. Kgnet can optimize the query based on user preference or based on integer programming optimization to select both the highest accuracy and lowest inference time models. We present 3 node classification and 2 link prediction tasks as Sparkle ML queries on real KGs. For example, the DBLP paper venue node classification task returns the paper title and URI and the venue predicted for each node. The user can for sure write their custom GML queries for further queries. This notebook is publicly available and provided in the paper text. Thanks.